Still got the island going on. That crap is slippery.
Smell that? Someone like your bacon.
Yeah, there's a very strong smell of weed out here today. Alright, we have all burners lit. Success. Now we just put her back together. Or Don will put her back together. While he's doing that, so that just had 2 or 3 pins. It had 3 pins on it. One there, one there, one there. Can't squeeze it open. These with the colored bands on them. Those are all resistors, different sizes. You can use those colors to determine what the resistance is of each of those. That's an LED light. These are little capacitors. We're used to big capacitors. And just like our capacitors, you can actually... Oops, I squeezed this one too hard. Can't tell on that one now. Let's just pull one of these off here. Break one of these off here.
47.
Can you see it?
Yep.
Yeah, this one's
47 microfarads at 63 volts.
Yep. So that little UF, that's actually the symbol for microfarads. 47 at 63 volts. Couple little chips on here. Obviously this is a transformer. These are relays. These 3 black boxes. So 2 of those will be for coil. That has 3. And probably had a normally open, normally closed 24 volt coil. DC. Take a peek inside. Of course, I crushed it a little bit. There's the actual contact itself. So you see inside there is a coil. That little tiny spider web looking wire right there is wound around and around that coil. And when it would energize, it would pull this down normally. It would come magnetic right there at that big silver round piece and pull this down and make the contact cross from here to there. You had one below, one above. This contact was on top of that, and this one's below it. So one position was normally open, another position was normally closed. It'd be sprung against the top until the coil energized. It would pull that down and then make the connection across there. And this whole bar right here would have been the common. This big blue one right here looks like it's a different capacitor, and it's actually kind of rusted and broke out on its own. Potentially been the problem the whole time. It was underneath there. Like a little burn mark right there. That's rusty looking, and I did not break this. So that was already like that. So that's probably where our malfunction was on this board. Our spark connected here. If we look, this comes over, oops, not that one. This leg, which was connected there, comes right over and comes right over to there, which is underneath there. So this capacitor was not getting any juice. The other side's hooked to there, which is another leg right there, soldered in there. and there's the other side of the capacitor. So from there to there, we can see that's all connected, but it's broke, so it could not get back. So interesting, complicated, but fairly simple once you start breaking it down and following it, because essentially this board, each one of these would just be a wire in a system. It's going somewhere. We normally have wires going to capacitors, and it's just all integrated into the board